Okay, guys, we'll just wait for 5 more minutes and we'll start the session. I hope I'm audible though. Manzoor, Guru, CK.
Yes, you are audible.
Perfect. This is going to be our first session, guys. We'll talk about basic networking fundamentals. What are IP addresses? IPv4 specifically. What are public IPs? What are private IPs? Okay, so this is one of the first prerequisites actually. If this is your first session, this could act as your demo class as well. Okay, so let's just wait until the others join as well. Won't be delaying much further. We'll start the class in 2 minutes. Okay, guys, let's get started without any further ado. Now, in today's session, we're going to talk about IP addresses. So when you talk about networking, there are two common definitions that you come across. First is a host, and then second is something called as a network itself. When you talk about a host is any individual information system or an information device which is capable of sending data and receiving data from other devices. So examples of that is as basic as your mobile phone or your laptop or your router or your smartwatch. Any device which is capable of receiving or transmitting data to other devices is called as a host. Now, when you have a collection of hosts which can communicate with one another, that forms your network. Okay, so at our home, we have a router to which all the other devices are connected. So you have your phones, your laptop, your smart TV, or whatever it is connected to the router. And this forms your internal network, your private network. And just like how we humans communicate with one another, we use our names to address each other. I call you by your name respectively, and you address me by my name as well. Similarly, Devices also have names, and these names are called as IP addresses. IP stands for Internet Protocol. This was developed by the US military in the late 1950s. Okay, there was IP version 1, IP version 2, IP version 3. These were not so successful. They were experimental. What perfectly worked out was IP version 4, and we're still using IP version 4 even in today's world. IP version 4, Internet Protocol version 4, is a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros and ones consecutively. A bit is the smallest data format, and computers communicate in the language of bits itself. Bit is either 0 or 1. Okay, and this language of zeros and ones is also sometimes called as binary language. Okay, and computers communicate, or information systems communicate with one another fundamentally in binary language, in zeros and ones. Okay, it's like off signal and on signal. Okay, now what we humans understand usually is the decimal language, decimal numbers from 0 to 9. So today we're going to learn how do we convert a binary number to a decimal number, okay, to a human readable number. Before that, a quick again, a few important details on IPv4 addresses. It's a 32-bit address, and this 32-bit address is divided into 4 equal parts. Okay, as you can see, 8 bits each, and each of this 8 bits part is called as an octet. Octa relates to 8. Okay, octet or a byte. 1 byte is equal to 8 bits of data. Okay, and each octet or byte is separated by a dot symbol. Okay, what you see here is the binary representation of an IPv4 address. Okay, now before we convert this binary number to a human readable decimal number, a quick recap on data sizes. Okay, 1 bit is equal to 0 or 1. 8 bits becomes your byte. Okay, and when you have 1024 bytes approximately, or close to 1000 bytes, that becomes your kilobyte. A KB is 1000 bytes. When you have 1024 kilobytes, that becomes your megabyte. Usually this textpad file or any documents are usually in kilobytes of storage. Your images are usually in megabytes of storage. 1024 megabytes becomes a gigabyte. Your movies or your huge again audio files or again applications or games are in gigabytes of storage. 1024 gigabytes becomes a terabyte. Our hard disk storage, our hard drive is in terabytes. Okay, and 1024 terabytes is 1 petabyte. We usually never come across petabytes in our systems. Petabytes is used by cloud organizations when they have to store data of thousands of their clients. Okay, they would use petabytes of storage. Okay, again, all of this breaks down to finally, fundamentally at zeros and ones itself, binary data. Okay, now let's try to understand how do we convert this binary number to a human readable decimal number. Okay, so I'm going to take the first octet here, 10101010, and I'm going to convert this now to a human readable decimal number. So I've written down the same octet here. If you notice, 10101010. Okay, now there are 2 steps of converting a binary number to a decimal number. Firstly, we need to write down the values from 2 power 0 all the way up to 2 power 7 from right to left. Okay, why specifically 2 power? Because this is a binary address, it contains only 2 values or 2 possibilities. Okay, again, 2 power 0, anything to the power 0 is always equal to 1. It's a mathematical rule. 2 power 1 is 2 itself. 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128. So you write down all those values from right to left first, and then in order to calculate the decimal equivalent, you multiply the lower number with the top one and just keep adding with the next one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 and finally 2 power 7 into 1. So if we calculate that now, 2 power 0 into 0, that's 0 again. Anything into 0 is 0 itself. 2 power 1 into 1, 2 power 1 is 2. So into 1 is the value itself. Oh, 1 second guys, let me arrange the data here. Just a second. Okay. Yeah, better. So as you can see, 2 power 0 into 0, that's your 0. 2 power 1 into 1, that's 2. 2 power 2 into 0, again 0. 2 power 3 into 1, 2 power 3 is 8. So into 1, 8 itself. 2 power 4 into 0, again 0. 2 power 5 into 1, that's 32. 2 power 6 into 0, that's 0 again. And finally 2 power 7 into 1, that's 128. So if you add all this up, 128 plus 32 plus 8 plus 2, you would get the number 170. So when we humans read the number 170 as 170, the computer or any information device reads it as 10101010. This is the computer or the binary translation for the decimal number 170. Okay, is this clear, guys? Again, if you have any questions or doubts, please let me know. You can interrupt me at any certain point and ask your questions. So is this clear? The binary to decimal conversion, guys? Manzoor, Guru, CK.
Yes, clear to me, sir.
Perfect. Guru, CK. Okay, perfect. Now, again, the reason I'm trying to show you this binary to decimal conversion, guys, is so that we can understand the range of the complete IPv4 addresses. Okay, so this is one of the octets which I've shown. Similarly, you can calculate the other octets as well and get their values. But if we wanted to get the first IP, all we have to do is put all the values as 0. Okay, so if you want to get the first IP, the least IP address you can form is with all zeros everywhere. So when you put all zeros, it would be 2 power 0 into 0 plus 2 power 1 into 0 plus 2 power 2 into 0, all the way up to 2 power 7 into 0. And you would get the first IP as 0.0.0.0 itself in decimal. And if you want to get the last IP, the maximum number you can get is by putting all ones. Okay. And if you put all ones, what happens? You would have 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1, all the way up to 2 power 7 into 1. So that would give you as 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 120. And if you add all of it up, you would get the number 255. So the last IP address would be 255.255.255.255. This is the first IP and this is the last IP. So now you logically understand why we would never have an IP above 255. Okay, so an IP address in IPv4 range can never cross the value 255. The reason being, each octet has 8 bits, and in all these 8 bits, if you put all ones, the maximum value or the maximum number it can translate up to is 255. So you would never see an IP like this, 127.256.300.500. This is an invalid IP address. Any octet will only range from 0 to 125. I'm sorry, 255. Okay, so it can never go in the negatives or above the number 255 base. This is the range of IP addresses, the first IP and the last IP. Now let's talk about the sequence of IPs. So we know this is the first one, we know this is the last one. What about the IPs in between? What sequence are they following? So in order to understand the sequence of IPs as well, there are two simple rules, guys. Rule number 1, always start with the rightmost value. Okay, so if this is my first IP here, let me zoom in a bit. Yeah, ignore these numbers, guys, on the right side. This was just a different representation. You can ignore these for now. Just focus on the IPs on the left. Okay, so if this is the first IP, 0000, the next IP would be 0001. So rule number 1, always start with the rightmost value. So increment the rightmost value by 1. So next IP 0002, next IP 0003, next IP 0004, next 0005. This goes on all the way up to 6, 7, 8, 9, 10, 11, 12, up to 255. Now, after 255, you cannot have a number like 256. This is not practically possible in IP addresses. So the maximum an octet can go up to is 255 itself. Now, after that, what happens? So once an octet reaches the maximum value, then the left value increases by 1. Okay, so only after the rightmost octet has been completely filled, then go to the left value. Okay, and reset the rightmost values back to 0. So this 255 becomes 0 again. It cycles back to 0. And now this 0 changes to 1. Okay, now after 0010, don't directly jump to 0020. That would be wrong, guys. Remember rule number 1, always start with the rightmost value. So after 0010, next IP is going to be 0011, then 12, then 13, then 14, 15, 16, 17, goes all the way up to 1255. So the same cycle is repeating here. If you notice, whatever repeated from 00 to 0255, same cycle repeats again from 10 to 1255. Again 20, 21, 22, 23 up to 2255. Again from 30 to 3255. Then 40 to 4255. Like that, it goes on all the way up to 2550 to 255255. Okay, so 2550, 2551, 2552, 2553, all the way up to 255255. Now, what happens now after that? Rule number 2. Okay, after the rightmost octet has been completely filled, then go to the left value. So this 255, 255 reset back to zeros, and then this 0 now changes to 1. So I hope you're getting the cycle, guys. Okay, once it reaches 255, it always cycles back to 0, and the next octet increases by 1. Okay, so whatever cycle repeated from 0, 0, 0 to 0, 255, 255, same cycle repeats again from 1, 0, 0 to 1, 255, 255. Okay, so what happens again? Assume this is 0, 0. So 0, 1, 0, 2, 0, 3 goes up to 0, 2, 5, 5, 1, 0, 1, 1, 1, 2 up to 1, 2, 5, 5, 2, 0, 2, 1, 2, 2, 2, 3 up to 2, 2, 5, 5, all the way like that from 1, 0, 1, 2, 5, 5, 0 to 2, 5, 5, 2, 5, 5. Okay, then now this 1 changes to 2. Same cycle again. Whatever repeated from 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5. Same cycle repeats from 2, 0, 0 to 2, 2, 5, 5, 2, 5, 5. Again, next what happens? 3, 0, 0, 3, 0, 0 to 0, 3, 2, 5, 5, 2, 5, 5. Next, 0, 4, 0, 0 to 0, 4, 2, 5, 5, 2, 5, 5. Okay. Finally, somewhere down the line, you're going to have 0, 2, 5, 5, 0, 0 to 0, 255, 255, 255. Okay, so if you scroll down, you can notice I've mentioned that as well. So from 0, 25500, you go up to 0, 255, 255, 255. Now what happens again? After all the octets are filled, they cycle back to zeros again, and this last 0 changes to 1. So now whatever cycle repeated from 0, 0, 0, 0 to 0, 255, 255, 255, same cycle repeats again from 1, 0, 0, 0 to 1, 255, 255, 255. So if you go all the way down, you can see 1, 255, 255, 255. Again from 2, 0, 0, 0 to 2, 255, 255, 255, 3, 0, 0, 0 to 3, 255, 255, 255. And finally, last cycle, 255, 0, 0, 0 to 255, 255, 255, 255, the last number. So this is how you have the first IP here and the last IP here, and this is how you're cycling through all the IPs. Okay. Now, if you were to ask me how many IPs are there in total range, so that would range from 255. I mean, each octet is cycling 255 times if you closely observe here. So you have 4 octets over here. So in order to get the total number of IPs, you would get it by 255 into 255 into 255 into 255, and that would give you 4.3 billion IP addresses. Okay, so in the short span of duration, this last 5 minutes, we cycled from the first IP to the last IP, 4.3 billion IPs. Okay, is this clear, guys? Has everyone understood the range and how do you calculate the sequence of IPs? Manzoor, Guru, CK. Do you want me to explain it again, guys? If you want me to, I can explain it in a much better way, much simpler. I can try to explain it with some examples also. Although, any questions? Guru, CK. Perfect. Now, my question to you guys right now is, so I've told you that there are 4.3 billion IPs, guys. Now, according to you, do you think these IPs are sufficient today? So if each person got a singular IP, are 4.3 billion IPs sufficient in today's world? Definitely not, because the population itself is close to 8 billion today. Okay, and each person again can have multiple devices. I myself at home, oh yes, I think it reached 8 billion, Guru, if I'm not wrong. I don't know, the last I checked, in this year we crossed 8 billion, I guess. Not sure though. But yeah, as I've mentioned, each person again can have multiple devices again. I myself can have one phone, I can have one laptop, I can have a smartwatch, I can have a smart TV, I can have a router again. Okay, so each person has multiple devices. Okay, so if each person at least maintains 2 devices on average, you would still need like 16 billion IPs. But we only have 4.3 billion here. So they figured this problem out eventually, after a few days, or I don't know when, but eventually they figured out that these 4.3 billion IPs might not be sufficient. In 1950s, when they developed the IP addresses and all, we never had these many devices. They thought 4.3 billion IPs are going to be sufficient for a very long time. But the internet grew so fast that they quickly realized these 4.3 billion IPs will again be shortcoming in the few years. So that is why they came up with two solutions. Solution number one was they divided these 4.3 billion IPs into two categories. There's something called as public IPs, and then there's something called as private IPs. Okay. And when they knew that this solution also might not work out, they came up with a much larger version of IP addresses, which was IPv6, okay, which is a 128-bit address. It's 4 times the size of IPv4 in length, and it has trillions and trillions of IPs. We'll talk about IPv6 at a later date, okay, but in the upcoming classes, we'll talk about IPv4. We'll stick to IPv4, and I'll explain about public and private IPs and why IPv4's solution of public and private IP is still going to fail someday, eventually. Okay, so let me define these IPs now first, public and private. So again, as I've mentioned, guys, in these 4.3 billion IPs, there are these two categories. So if I draw this out, if I have to separate this with a box or so, okay, so oh, just a second. Let me draw this out. Yeah. So if we take this box as the whole 4.3 billion IPs here, this green colored box, IPv4 addresses, okay, and in total, how many do we have? We have 4.3 billion IPs. Okay, now I've told you that there are two types of IPs, public and private. But again, along with this, there's one more categorization as well, called classes. So what we have is we have 5 classes actually: class A, B, C, D, and E. So let's assume each of these smaller boxes is each of the class. Okay, so we have class A here, class B here, class C here, class D, and class E. And now we have the other categorization. So if you remember, I've told you they're public IPs and private IPs again. So class A has a few public IPs in it and a few private. Class B also a few public and few private. Class C also a few public and few private. And in class D and class C, there are no private IPs. All of them are public itself. So in class A, as you can notice, there's a few public IPs and a few private IPs. Similarly, public and private. Similarly, public and private. Okay, in class D and class C, we have no private IPs. All of them are public itself. Okay, there are no private IPs in D or E. Okay, so let's talk about this public and private in today's class, and we'll talk about the categorization of these classes A, B, C, D, and E in the next class. Okay, so what is public and what is private? So when you have an internet connection at your home, guys, so if you notice at your home, you might have a router. Okay, so if I draw this out, let's assume this circle is the router at your home. Okay, this router now is wirelessly connected with all the other devices at your home. So you could have a mobile phone, you could have a laptop, you could have a smartwatch, okay, or you could have a TV. Okay, all of these devices are the internal network devices in your own local network. Okay, oh, just a second. Yeah, let me move this to the side. Okay, so in your own home network, guys, whatever local network that you have or your own personal network it is there, that network is called as your private network, also commonly called as the intranet network. And these devices are connected to the router, to the Wi-Fi router that you have wirelessly. Okay, so each of these devices is connected to your router here. Okay, now when they want to communicate with one another, they need their addresses. So each of this device gets a private IP. So all the local devices that you have at your home locally in the intranet network, they each get a private IP. Similarly, your router also gets a private IP. So it usually gets the first private IP in the network. So let's assume this is PR1. And then there's your phone. Let's assume that got PR2. Then there's PR3 here, private IP3. Then there's PR4. Okay, and then there's PR5. Okay, each of these got a private IP. Now, when these devices want to communicate with the internet now, so let's say there's this organization over here, okay, and there's this website called google.com, www.google.com. Now, when you take the internet connection, guys, you take it from someone called as an ISP, Internet Service Provider. So in India, we have ISPs like Airtel, Act 500, Tata Docomo, and so on. So, okay, so these organizations provide you the service of internet, and that internet service provision is happening with something called as the public IP. Okay, so they provide you a public IP here to connect with the internet. So whenever one of your devices requests for the website Google, so let's say if you're trying to access Google from your mobile phone, the connection first comes from your device, from your mobile to the router. So there's a connection made from private IP2 to private IP1. From private IP1, a router acts as a network divisor. Okay, it is acting as a gateway here. It communicates or translates your connection from the private network to the public network. So from private IP1, the packet travels to the public IP. From there, with that public IP, it reaches the ISP, and from the ISP, it reaches the target server, google.com. And this is how the packet travels. And this is where you're using your public and private IPs. Private IPs are the IP addresses used in your local LAN network. Okay, so if I draw this out in a different color, let's assume this blue color box that you have over here, this is your private network. Okay, and outside the router, okay, if I just move this a bit, just a second, guys. Yeah, if I just move this a bit to the side. Yeah, yeah, much better. So if I just draw this box here, these are your private IPs. And on the right side, this other red color box that you see, oh, sorry, this red color box is your public IP network. Okay, private IPs are your local IPs used in your LAN area, in your local area network. Public IPs are the IPs provided by the ISP to connect to the internet. And the router acts as a medium between the private network and the public network. Okay, again, very important point to note, guys. When you want to connect to the internet, you always need a public IP for it. Unless and until you have a public IP, you cannot connect to the internet. In the internet connections, if I want to send some file from my laptop to my mobile phone, or from my laptop to my smartphone, or so, or a smart TV or smartwatch or whatever it is, private IPs are sufficient for that. For local connections, for local communications in your own local network, private IPs are more than sufficient. But when you want to connect to the internet, you definitely need a public IP, which is provided to you by an internet service provider. Okay. And if you want to check your public IP, all you have to do is go to your browser and search for what is my IP. And with that single search keyword, if you get your public IP mentioned here. Okay. If you want more information on this public IP, like who is providing the this public IP to you, what is your ISP, you can click on any of these websites, whatismyip.com or ipaddress.com, and they tell you who your ISP is. Beam Telecom is basically Act 500. Okay. So yeah, this is how you check your public IP, guys. If you want to check your private IP, you just open up the command prompt, and in command prompt you run the command ipconfig, which stands for IP configurations. And when you hit enter, it shows all the private IPs your system is getting. Right now I'm connected to my Wi-Fi. So if you check in my Wi-Fi adapter, this is the private IP I have, 192.168.0.4. Now, why did I get specifically this IP? What does this 192.168 mean? We'll talk about all that in the next class, guys, once everyone joins. So this is just a demo, guys, for you on basic networking concepts. Not all the students have joined today. Some students have made the payment, but probably they'll be joining from Monday. So again, on Monday, I'm going to repeat these same concepts again, guys. Okay. So again, but Monday, the link is going to change. If you have not made the payment yet, please do make the payment. Okay. And on Monday, if you have again not understood something, we're going to take the same concepts again for all the other students. I'm going to explain a bit more in detail about this public and private IPs as well. Okay. So yeah, that's that, guys. Nothing further. This is going to act as a demo for people who have not joined the demo until now. And yeah, that's it. Nothing further. Any questions, guys? Guru, Manzoor, CK?
Yes, sir. Questions.
Mm-hmm.
Sir, when
Yeah,
you
Manzoor.
search for, yeah, when you use your internet browser, the public IP was shown. So
Uh-huh.
was that public IP of your router?
Yeah, again, as I've mentioned, that public IP is given to your network, Mansoor, to your connection. So that public IP goes to your router itself. But when you communicate with any system in your network, all the devices get the same public IP on it. So when I'm using my phone or my laptop, my packet goes from my laptop to my router, okay, to which the public IP is connected. Okay. So it is connected to your router, but it is acting as the same public IP for all your devices in your network. Okay. So it is not specifically only for router. Any device that connects to the internet has to connect through the router, and the router gets that public IP. Okay. Is that clear?
Yes, so other device in your local or private network would have got the same IP, public IP,
Definitely. No
right?
matter
No?
what device you check from, yeah, no matter what device you check from, all the devices will still show you the same public IP only, because they're connecting to the same router, which is connected to the same optical fiber cable coming from the ISP, providing that one public IP. Okay.
Okay, got it. Another question is, in case I use my mobile phone, I do not, I'm not on any network, so will my mobile phone get the separate public IP address because it does not have router, or am I
Yeah,
under?
again, if you're not connected to the internet, Manzoor, you will not get a public IP. So on your phone, let's say you're not connected to any network and you have not even switched on the mobile data, then your device will not at all get a public IP as well. But as soon as you switch on the mobile data on your phone, your SIM card fetches the public IP from the ISP. Okay, so your SIM card could belong to Airtel, Idea, or whatever it is. That SIM card has the option of getting a public IP when you have a data plan. Okay, so your SIM card will provide the public IP in that situation. Okay.
Okay,
Exactly.
so yeah, so every SIM card will have its own public IP.
Not like that actually. There's a separate concept for that called natting actually. Okay, where each IPs that you might get is something based on IPv6. Okay, so you could say it will be unique, but it's dynamic. It keeps changing from time to time. It's not going to be unique to you. Today you might get that IP. Tomorrow someone else might get that IP. Okay, it's not fixed for your device. Okay, it's always dynamic. It's always constantly changing. Okay, but yeah, if you are getting that IP at that date, it is unique to only you. Okay, no one else on that same day will get the same public IP. Okay, is that clear?
Yes, yes, it is. And the last question, when you typed IP config, there was IP address for the default gateway as well. What is that?
Yeah, as I've mentioned, even the router gets a private IP. The router's address is called the default gateway address. We'll talk about that in the next class, Manju. So we have a concept for that. So I'll mention what this default gateway is, what the subnet mask is. We'll talk a bit more in detail about that. But whenever your device needs to communicate with the internet, it needs to know the router's address. And that router itself is called as the default gateway, the first IP in your LAN network. Okay, this is your IP address. This is the router's IP address.
Oh, so okay. So default gateway is the router siding. Okay.
It's the
Yeah.
router. Exactly.
Okay. Thank you.
Right. So we'll talk about a bit more on in depth about that, guys. What is this subnet mask? What is this default gateway? Why it is called default gateway? Okay. So we'll talk about all that in the upcoming sessions. So yeah, that's it, guys. Nothing further. I want you to join the next class. Again, please register for the course if you have not already registered. And the link is going to change from Monday, and it will be provided only to the people who have made the payment for the batch. So yeah, that's it, guys. Nothing further. I'm going to exit the session, and I'll see you on Monday again. Bye bye.
Okay. Bye. Thank you, sir.
Thank you, guys.